Hi, basic geometry students. I wanted to review a topic that I know was difficult for many of you, which was located on the 7.2b homework. So within this concept of similarity, specifically that learning target that was a little bit more challenging was using the parameters of similar figures to find missing side lengths. So to remind you, the main fact that we are going to be using here is that when two polygons are similar, the ratios of their parameters is going to be equal to the ratio of those corresponding side lengths. So in other words, the ratio of the parameters is going to be the exact same as that scale factor. Alright, so on number 1, the information given to us is that the parameter of this smaller triangle is 30, which is helpful because we don't currently know any of those side lengths. So we said since the ratio of the parameters is equal to the ratio of the side lengths, let's find the parameter of the other triangle as well. Okay? We know parameter means the sum of all of those outside lengths. So we're going to add 12 plus 15 plus 18, and that'll give us the total parameter of the larger triangle, which is 45 units. Okay? So let's find our scale factor, because that's going to be equal to the ratios of the parameters. And since we always want to be consistent when we're comparing, in this chapter, I'm going to compare the small triangle's parameter, 30, to the large triangle's parameter, 45, and reduce that fraction. So since 15 goes into both 30 and 45, if I divide both numerator and denominator by 15, I get a reduced scale factor of 2/3. Alright, so now we are capable of finding those missing side lengths. What we're going to do every time is compare the ratio of the parameters, 2/3, to the side lengths we want to find. Okay, so let's say we want to find x first. Okay, x corresponds with 12 on the other triangle. So I'm going to be comparing those two sides. Okay, and so I'll start there. And we said, well, we're always going to go small to big. So I'm going to say small side x, or I should say small triangle x to its corresponding side length in the big triangle, 12, is going to be equal to 2/3. And now I can use the cross products property to solve this. So I multiply x times 3, which is 3x, and set that equal to the product of the other diagonal, 12 times 2, which is 24. And if I divide both of these by 3, I get x equals 8. So I have one of my 3 answers. Okay? So for the next side length, let's say we want to find y next. I'll use green. Y corresponds with 15 in the big triangle. So I'm comparing small triangle to big triangle. So I'm going to start with y small triangle to 15 big triangle equals 2 to 3, the ratio of their parameters. Once again, I solve this by using the cross products property. So I multiply 3 times y and set that equal to 15 times 2. And I divide both sides by 3 to get y equals 10. Alright, and one last one is z, which as you can probably see corresponds with 18. So my setup to find z, let me scooch down here a little bit. My setup to find z would be z over its corresponding side length in the big triangle, 18, equals the ratio of their parameters, 2 to 3. Solve it using the cross products property. So z times 3 equals 18 times 2, which is 36. And then divide both sides by 3. And 3 goes into 36 12 times. So my final answer is x equals 8, y equals 10, and z equals 12. And we use that all just by comparing the perimeters of the two figures. Okay, so now I want you guys to practice this. Apparently that's staying there, so I guess we're going to ignore that. To find the value of each variable for each pair of similar triangles. Okay, so they give us the perimeter of this triangle. Oops, I need to go back to the pen. Is 51. So your first step is find the perimeter of triangle ABC. Perimeter means sum of the lengths of the outsides. So 24 plus 32 plus 46 gives us a total perimeter of 102. Okay, question 2. Find the scale factor or the ratio of the perimeters from small triangle to big triangle. So from triangle DEF to triangle ABC. Alright, correct answer there would have been, so the perimeter of a small triangle is 51, that's given to us. The perimeter of the large triangle is 102, we just found that. And you do always want to check to make sure that that doesn't reduce. And it does, that reduces to 1/2. So that would be the correct answer, 1 to 2. Okay, next question. Can I erase this? Maybe I can't. I guess I'm just going to leave it alone. Next question is to use the ratio of the perimeters, so 1 to 2, to find the value of x. Okay, correct answer here would have been, first, find what x corresponds with in the large triangle 32. So our setup would be x to 32 equals 1 to 2. Okay, and solving this, we would have 2x equals 32, divide by 2, and get x equals 16. Alright, next question. Use the ratio of the perimeters to find the value of y. Alright, y corresponds with 24, therefore your setup would be y over 24 equals, go back to the ratio of their parameters, 1/2. And using the cross products property, you would see 2y equals 24 times 1. And in dividing that by 2, we get y equals 12. And just remember, this is from the previous problem, so scratch that. Okay, last question. Find the value of z. Alright, z corresponds with 46. Therefore, your setup would have been z over 46. It's a 4. Equals 1/2. Going back here, okay? Solving this, we would have 2 times z equals 46 times 1. And if we divide 46 by 2, we get the value of z is 23 units. Alright, hope this helps. If you have any questions, let me know.